Certain features must be positioned specifically relative to other entities. This tutorial will discuss the construction of these features, beginning with holes. The command used for creating holes may be accessed from the Insert Design Features menu. There are three kinds of holes. They are simple, counterbore, and countersunk. We will start with simple holes. To begin construction, you must first select a placement face for the hole. You now have the option to either select a through face, which will create a hole through the entire length of the part, and which will remain through the entire length of the part, even if you edit the feature's diameters. Or you may enter dimensions for the hole depth and tip angle. The second option is a counterbored hole, which will create a larger diameter excavation at a short depth from the placement surface of the hole. Again, you must select a placement face and specify the depth, diameter, and tip angle of the hole. In addition, you must also choose a counterbore diameter, which must exceed the diameter of the hole, and a counterbore depth, which cannot exceed the depth of the hole. The third option is countersink. This type of hole is very similar to counterbored holes, but has an angled top portion. In addition to the options available for simple holes, you must also determine a countersink diameter, which will be the diameter where the hole pierces the surface, as well as a countersink angle. This angle will determine the depth of the countersink. After determining the dimensions of your hole, you must position it. A positioning dialog will open after specifying your hole geometry. The default dimensioning technique is to position a hole perpendicular to a reference line. To use this technique, you must simply specify the target edge from which to reference your hole. The center of the hole will then automatically be chosen as the reference position for your tool feature. Therefore, a dimension will be created from the center of the hole, perpendicular to the selected reference edge. To fully constrain a hole, you will need to perpendicularly reference it to two different lines. The status bar at the top of the screen will display whether the feature's positions are underspecified or whether it is fully constrained. Be sure to choose Apply rather than OK if you are not finished dimensioning your hole. Choosing OK will exit the positioning dialog, whether or not your hole is completely constrained. Once you have fully specified your hole, the dialog will automatically exit and your hole will be created. Some more popular dimensioning techniques for holes are point-on-point, which is used to match the center of a hole to a specified point. Or point-on-line, which will center a hole along a line. After choosing point on line, you will also need to use another positioning option to determine the location of the hole along this line. You can also reference your hole with the horizontal or vertical options. These options will first prompt you to select a horizontal reference, which will determine the horizontal and vertical directions when positioning. It is possible to create a hole without positioning dimensions. However, this is not good modeling practice, since future editing may produce undesirable results in hole location. If you forget to input positioning dimensions, you may right-click on the hole and choose Edit Positioning, which will take you back to the positioning dialog. The slot command lets you create a passage through or into a solid body. This command is found in the Design Feature menu. There are 5 different kinds of slots. The first is rectangular, which allows you to create a slot with sharp edges along the bottom. To create a slot, you must first select a planar placement face and a horizontal reference. This reference will determine the orientation of the slot. For example, if you wish the slot to run diagonally across a planar face, you may create a datum axis from corner to corner of the face, and then choose this axis as the horizontal reference. You must then specify length, which is measured parallel to the horizontal reference, width, and depth. The positioning dialog will then open. To position, the first object you then select will serve as the target from which the slot will be dimensioned. Next, you will be prompted to select a tool edge, which will be the edge or center line of the slot to which the dimension will be created. You may choose to dimension the angle of the slot with reference to an edge, which will change its orientation. Another option is to use the parallel constraint, which will specify the distance between 2 points measured parallel to the work plane. If you choose edges rather than points, the endpoint nearest the pick point is selected. You may also select parallel at a distance, which constrains the selected edges to be parallel and a set distance apart. The second option for creating slots is the ball end, which creates a slot with a full radius cut along the bottom corners. Construction of a ball end slot is much the same as that of a rectangular slot, except that you must specify a ball diameter, which will also be the width, along with the slot's depth and length. For this option, the slot depth must be greater than the specified ball diameter. The next option is the U-slot, which is similar to the ball end slot, but lets you add rounded corners with a floor radius rather than a full floor diameter. This radius must be less than half of the width of the slot and less than the depth. The next option is a T-slot, which creates a slot with a cross-section of an inverted T. For this command, you must specify the top width, top depth, bottom width, bottom depth, and length. The width of the bottom section must be larger than that of the top section to create a T-slot. Also, for this option, bottom depth is not distance from the placement face to the bottom, but rather the size of the actual bottom part of the T. The final option is the dovetail slot, which creates a slot with angled walls and sharp corners. To create a dovetail, you must specify the width, depth, angle, and length. The angle will be the angle between the slot floor and the side wall, and the width is the width at the placement surface. Through slots can also be created to define the length of slots by checking the box labeled Through Slots when selecting the slot type. When using this option, you will be prompted to select the starting and ending through faces rather than a length. The slot will then be created until it has intersected both of these faces and will always run the entire length of the feature it has cut through, even if the feature's dimensions are edited. A boss is a cylindrical feature that is added to an existing feature via a planar face or datum plane. The boss command is found under the Insert Design Features menu. The first step to creating a boss is to specify a placement face. The boss must be placed on a planar face or datum plane. The boss will be associative with this plane. If you select an absolute datum plane for the placement face, and more than one solid is present in the part, a target solid selection step becomes available, which you must use to select a target solid for the boss. Bosses cannot be created independently of another feature. You must then simply enter a diameter and height for the boss. A taper angle can also be specified which will reduce or enlarge the angle of extrusion of the cylinder depending on whether it is positive or negative. If your boss was placed on a plane rather than a feature face, you may also choose reverse side, which reverses the temporary direction vector of the placement plane and thus the boss extrusion direction. The last step is to locate the boss with positioning options. Rectangular pads are like rectangular versions of bosses. This option is located in the Design Features menu as well. As with bosses, you must first select a placement face, which must be a solid planar face or datum plane. You will then be prompted to define a horizontal reference. This reference will determine the pad's orientation along the planar face. You will then need to specify the dimensions for the pad on the placement face. In addition to dimensions for length, width, and height, you can also specify dimensions for taper and corner radius. Corner radius will create edge blends of the specified radius on all 4 vertical edges. Finally, you must again use the positioning options to position the pad. One option available for rectangular features such as pads is the placement option Line on Line. This allows you to line up the edge of a pad with another edge, thus allowing you to make the pad flush with the attached feature. Pockets can be used to cut shapes into pre-existing features. The Pocket command is located in the Insert Design Features menu. We will focus on rectangular and cylindrical pockets. General pockets can also be created, but will not be discussed in this tutorial. Rectangular pockets are much like pads, but are subtracted from features rather than added. The command used for creation are much the same as that for pads. You must select a planar placement face and horizontal reference, then specify the length, width, and depth. You may also enter a floor radius, which will create a fillet along the bottom of the pocket, a corner radius, which will create fillets along the vertical edges of the pocket, or a taper angle. You must then attach the pocket using the positioning options. Cylindrical pockets are much the same, but require specification of a diameter rather than a length and width.